Hello, my name is Snigtha Mohanraj. I'm in 8th grade at the Engineering and Science University Magnet School. My project was called the Ferro-Sponge. Oil in our water has been a huge issue that has yet to be fully solved properly, but it has gained a lot of attention recently. Many people have learned about how toxic it is and how it can really harm us, but a lot of people don't know about microplastics and how those hurt us. Microplastics are pieces of plastic that are less than 5 millimeters in size. They can be toxic or transport toxic pollutants. But this issue, even as a whole, still needs to have an effective, non-toxic solution found. Current methods for removing microplastics from water include using inorganic synthetic coagulants that are toxic for the environment and not cost-effective. Current methods for removing oil from water include in situ burning, which contributes to global warming and pollutes air quality. It is important that we find an effective and environmentally friendly solution to remove oil and microplastics from our water. This year, in a recent project, I looked into the usage of metal oxides with an electromagnetic filter to remove microplastics from water. This worked quite well since microplastics have a negatively charged structure and agglomerate with the metal oxides, and these aggregates would then be attracted to the electromagnetic filter used. This was a viable solution for removing microplastics, but I wanted to look into a more accessible and easily implementable solution based off of using these metal oxides. The project I conducted also told me that iron oxide is a very effective metal oxide to use for removing microplastics. In this project and the research behind it, I learned that metal oxides can also remove oil from water. So from this experiment as a whole, I was inspired to use iron oxide to remove microplastics and oil from our water. This would work effectively because since microplastics are not polar, they stay suspended in water, but are rather attracted to the metal oxides. The Ferro-Sponge attracts the microplastics because of this. A similar concept also applies to oil, as it is also nonpolar and thus attracted to the Ferro-Sponge. Now, by simply cleaning the Ferro-Sponge, microplastics and oil can be removed from water. This will help keep us, other organisms, and the environment safe from their adverse effects. In addition to this, I also wanted to use bentonite, as it has good oil removal capabilities. I decided to implement this idea by using a sponge. To make my Ferro-Sponge, I mixed the iron oxide with water and then added bentonite to create a sludge. So for my sponge, I created different sponges to see which consistency of the iron oxide bentonite water mixture would be best to use. It was shown that using 2 tablespoons of iron oxide, 1 tablespoon of bentonite, and 1 cup of water was the best to use. So this was the consistency that I used for my final design. I dipped a polyurethane sponge in the sludge and soaked it for 5 minutes. After the thorough soak, I put it in the oven at 70 degrees Celsius for about 1 hour until it was dry. I then thoroughly washed the sponge to remove any debris. I squeezed out any extra water and let it dry in the oven for 30 minutes once more. Now the sponge was ready to use. A microplastic sample was created for testing by using a recyclable plastic container and grinding it into fine pieces using metal rasp. These samples were passed through a sieve to collect only particles with a size of less than 5 millimeters. The microplastic samples were then added to a bowl of water and thoroughly mixed. I also added oil. This created my contaminated water samples containing the microplastics and oil, similar to natural contaminations. The created Ferro-Sponge was placed into the contaminated water sample for testing. After 5 to 10 minutes, I removed the sponge from the sample and thoroughly squeezed it to remove the microplastics and oil. The sponge was again placed in the water, this time for about 30 minutes to remove more microplastics and oil. After this, 50% of microplastics and oil were removed from the contaminated water samples. These findings were confirmed by using a homemade spectrometer that I created by using recycled materials and a connected online software program. I also used a digital Wi-Fi light microscope to see the presence of the oil and microplastics. These two methods confirmed that at least 50% of microplastics and oil were removed from the contaminated samples by using the Ferro-Sponge. To make sure that none of the iron oxide will leak into treated contaminated water samples, I placed a magnet in the middle of the sponge to continuously attract the iron oxide back into it to prevent any accidental leak. Since all of the materials I used for my sponge were recycled, the entire prototype cost less than $5. These sponges can be manufactured in both smaller and larger scales, depending on where it would be used. The sponge can be applied for any contaminated water coming from any kind of household appliances, or even directly in the ocean where there are severe concentrations of microplastic and oil, and there is still no good way of removing them. Based on the size, my product would be sold between $5 and $500. The general usage of using the Ferro-Sponge for something like a faucet would be sold for about $10. Throughout all of my research, I could not find anyone who did this invention or something similar. There have been some methods of using iron oxide to remove certain contaminants, but nothing for removing microplastics and oil, and moreover, there has not been a way of implementing it into this easily usable sponge method. It is important to combat the presence of microplastics and oil in our water. The Ferro-Sponge is the way to go. Thank you for listening.